Suppose you were given the letters A, B, and C. And suppose you were asked, in how many different ways can you create a group of 2 letters? Well, the answer depends on your definition of the word different. I look at the letters A, B, C. If what you mean is, well, A, B is a group, A, C is a group, and B, C is a group, well, then the answer to the question would be 3. On the other hand, let's go to the left over here. Let's start with AB, then AC. Well, what do you mean by the word different? Because we could write BA, BC, we could write CA, we could write CB. Someone could say we have not 3 but 6 different groups. Well, the issue here is what? The issue is, does order matter to you? Does the order in which the letters appear from left to right matter to you? If it doesn't, then over here on the right, we have what? We have 3 combinations. 3 combinations of letters. That's when order does not matter. Order does not matter. On the other hand, suppose that order does matter to you. Well, then over here on the left, we're going to call these permutations. We would say in this particular case that we have not 3 but 6 order matters. Now, these questions can be pretty difficult, and they're actually unlikely to come up on the test unless you're looking for a score in the top 10%. And what you definitely will not see is a question that uses the phrase order matters or order does not matter. You're not going to get a hint on that. You have to figure that out yourself in the context of the question. Although you won't see the phrase order matters, you might see the word order. A word you may very well see, whether it's a permutations question or a combinations question, is the word arrangement. And again, depending on the context, depending on the exact wording of the question, your job would be to interpret whether they're looking for the number of permutations or the number of combinations. One word you might see in a combinations question is the word choose. In how many different ways can you choose certain items? For example, as we set up here, choosing 2 out of 3 letters. Now, before we go any further, there's one concept you need to know about: factorial. Factorial. And you need to know this for permutation and combinations questions, but you might also get a question about factorials that doesn't ask you to find a number of permutations or combinations. A factorial is the product of an integer and all of the positive integers below it. And it is expressed with an exclamation point. So for example, 4, if you see an exclamation point, that means 4 factorial. And it is the number 4 times the integers going down to 1. So in this case, 4 factorial would be what? 12 times 2, 24. You have to know this regardless of whether you invest a lot of time in learning permutations and combinations. Suppose we had 5 members of a company competing in a road race. Suppose we had Bill, Gary, Randy, Oliver, and Peter. And suppose the question were, in how many ways could 3 of these employees finish first, second, and third place? The person who comes in first could be any of the 5. Then the person who finishes second could be any of the remaining 4. Any of the remaining 4. Tough to fit all of that in. So up above, the first place finisher could be any one of the 5. The second place finisher could be any one of the remaining 4. Third place, any one of the remaining 3. In how many different ways could 3 of the 5 employees finish in the race? We'd be multiplying 5 by 4 by 3. The answer would be 60. 60 different ways, 60 different permutations. And you can see there's not enough room to write all 60. That would be a permutations question. Now, what would be a combinations question? Suppose the question were, out of the 5 employees, how many groups of 3 people could finish in the top 3? How many groups of 3 people could finish in the top 3 slots? Well, here's where it gets interesting. And on the left-hand side, let's add some more letters here. In the upper left, suppose we had BGR and BRG. And then going down a little bit, suppose we had GBR or GRB. And if we keep going, if the first place finisher were R, we could have RBG, we could have RGB. In other words, suppose we viewed these 6 different permutations as just one group. Well, then my answer to the question, it would not be 5 times 4 times 3. It would not be 60. If I view 6 permutations as really just one group, I would divide this number by what? 3 times 2 times 1. Where does the 3 times 2 times 1 come from? Create a little room here. Well, down here on the bottom, the first person in that group could have been any of the 3, and then the second either of the remaining 2, and then the other comes third. So I'd be dividing my 60 by 6. I would say there are 10 different groups of employees who could finish in the top 3. So a different question. And that's what you need to know. Those are the fundamentals of what you need to know in order to answer permutation and combination questions. Now, there are a couple of formulas I have to point out, but the truth of the matter is that knowing them makes these questions more confusing, not less confusing. So don't feel any need to memorize these, but for those who do want to see them, let's go to the top here. Suppose the number of items you're placing, we're going to call that n. So here n would equal 5. And in this case, for the combinations question, we wanted to choose a group of 3 people. Let's call that k. K is the number of people in the group. And we're running a little bit out of room here, but I think we can fit this in. Let's go down to the lower right. The formula for the number of permutations is n factorial divided by n minus k factorial. That's the permutations formula. In the formula for combinations, it starts with n factorial divided by n minus k factorial. But in order to get that number down, here we went from 60 down to 10. In order to get that number down, in the denominator, we're going to write k factorial. That's our 3 times 2 times 1. The idea is that we're now viewing these 6 as just different versions of the same thing. But in all honesty, it's better to forget about those formulas and just think about the reasoning we employed here. Now let's take a look at another combinations question. We're going to use the same 5 letters, B, G, R, O, P, but now they're going to stand for colors: blue, green, red, orange, purple. Suppose these are the colors of 5 jackets. And suppose we are asked to select groups of 3 jackets. Well, in this case, we don't care about the order in which the colors appear. For our purposes, B, G, R is exactly the same thing as all the other arrangements. So if you were to ask me how many groups of 3 jackets could I select that all had different colors, I would consider these all the same thing. So my answer would be 5 times 4 times 3 divided by 3 times 2 times 1. Here again, the answer would be 10 different groups. One final point. Permutations and combinations are just one subset of a bigger principle, the fundamental counting principle. We have our 5 employees again, and suppose that right after the race, they have to go out of town to one of 3 cities. And each city has the same 4, let's say, hotel franchises. And once the employee arrives in the city, he can stay in any of the 4. How can you count the ways in which a given employee could go to a given city and stay in a given hotel? 5 times 3 times 4. 60. We count the possibilities by multiplying. Employees, cities, hotels, these are 3 different sets of objects, so to speak, in no way related to each other. So you find the number by multiplying. So counting methods, those are all the fundamentals. Permutations, combinations, factorials, the fundamental counting principle. Everyone should know the very, very basics, but there's no need to spend a lot of time on this unless you want to score in the top 10%.